So let me quickly introduce myself as well as some of the work that we've been doing. And I do want to give a shout out at least to the OCP community in general in being able to get us involved within such a short cycle of us actually introducing some of the stuff that we've been doing. So there is a lot that I think we will be doing in the near future in terms of more collaboration with the OCP community, especially in light of some of the stuff that I do want to indicate today, as well as things that we'll be announcing hopefully within by the end of this year or mid next year. So to start off, I am Akshat Sharma. I'm a technical marketing engineer. I work on iOS-XR, in generally on top of Cisco hardware till today, but we've been talking about our disaggregated solutions for a little while, at least since March, when we announced iOS-XR running on some of the selected third-party network hardware that we started off on. As part of this talk, I'd like to be able to introduce some of the changes that we've gone through in terms of both the architecture of iOS-XR, our sort of experience enabling iOS-XR on top of third-party hardware. What are the changes that we did in iOS-XR, as well as what did we incorporate from the OCP community to be able to enable that integration. I'll talk about those, and hopefully if everything goes well, I'll show you a couple of live demos, both of XR running on top of some white box hardware, as well as pointers to what we have and what you can check out. Of course, we'll try and keep the questions hopefully to the end of the talk. I know we have only around 25 minutes, so I want to squeeze in both the information that you will need from my side, as well as the demos during the process. Right, so in determining the title of this talk, I guess it's hard to talk about how Cisco would enter the OCP community space as well as the generic white box community without addressing the fact that till today, Cisco, at least on the iOS-XR front, has primarily been a platform-driven approach, which means that we would determine our own hardware and we would sell our software on top of our own hardware. And the question therefore arises that as you go into the white box hardware space, what is the mechanism in which we were able to disaggregate the iOS-XR stack from the hardware, but also how will we be providing that to both to the community as well as to our customers. So in doing so, I generically call most of the effort that we've been putting both on the software side as well as the software hardware integration front, with respect to an allegorical reference that I call the journey to the West. Quite often, I call it a journey to the web for iOS-XR, particularly with respect to the set of APIs that we've developed over time, as well as some of the newer layers that we've been working with. Now, a quick reference on where that allegory sort of comes from. There is an old Chinese folklore called The Journey to the West, at least for the English audience. And it is a folklore about the Monkey King within the Chinese context. But to give you a quick snapshot of why this is related to what I'm talking about, Wu Chengyan is an old writer that basically wrote the storyline about the Monkey King, and it is actually based upon an older storyline of a person called Xuanzang in the 6th century AD, who set out for the West. Now, in those days, in the 6th century AD, when you consider West for China, the destination was primarily India. And the reason for that is that he went out looking for concepts of Buddhism that he could import and then completely change the Confucian culture within China. And therefore, this is what led to what we call Neo-Confucianism, where you were able to bring in some of the tenets of Buddhism and combine them with the practicality of Confucianism. And I sort of see that spiritual mixture of what Xuanzang was able to get from the Indian context and then combine it with the practical nature of what they were doing, much in terms of what we do also on the iOS-XR side. And the reason for that is that we started off much the same way in terms of building out our practical solutions for the customers that we have been dealing with on the service provider side for a very long time. And that is why much of our architecture, at least till maybe 4 or 5 years ago, was more or less hardware-centric. It was focused on running it on our hardware, exactly in the way that we'll be able to test and provide to the end customer. And you were guaranteed an SLA with respect to the overall platform, and not just the software or the hardware separately. What we started doing, however, about 2 to 3 years ago, is we started doing a sort of software disaggregation. When I say software disaggregation, I'm talking about slicing up higher layers of the software stack. I'll get to software-hardware disaggregation, but this was a first step. And the reason we were doing it was that as we dealt with a large number of use cases within the service provider space, whether this is core networks, data center interconnects, even backbone networks, etc., we found that a lot of the use cases was centered around being able to use your own software stacks or even software stacks from the generic open source community so that you can combine that along with whatever stacks you get from vendors such as Cisco, and then start solving a bunch of different use cases. So we started off primarily by disaggregating the software layer. And in doing so, of course, it may be fairly obvious to a lot of folks here that what you deal with on vendor stacks primarily is the management layer at the top, right? So that's where your CLI, SNMP, things related to the YAG models that most vendors expose come in. But as we started slicing up, we started exposing APIs at different layers. And the service adaptation layer that you see right in the middle there actually became critically important for some of these use cases. We were slowly getting towards a more disaggregated solution where we also start disaggregating the software and the hardware, but we found out that a lot of use cases were being solved simply by allowing our customers to bring their own controllers and control plane stacks to run on the network. So a lot of you might have heard about Facebook's announcement with OpenR, for example, and it forms a part of the community focus on bringing your own software stacks to the community. And we were able to basically use the APIs that we exposed at the service adaptation layer, get the OpenR stack integrated, run it on the system. So OpenR becomes sort of a mix and match between an open source stack and a vendor stack working together. But we couldn't stop there, right? So as we progressed further, we started disaggregating the hardware and the software as well. So you looked at the layers that we separated out on the software side. Let's go one step further. And we were able to then isolate that software infra system OS BSP layer that you see there, and then slice it up into a couple of important layers. One is make sure that on our side, that is on the vendor stack side, we were able to implement a higher layer API that allows us to move across different ASICs. Now, this would be both for us internally, for Cisco platforms, as well as for merchant silicon that are still handled by us. But in addition to that, we'll try and extend that further to white box hardware. So the disaggregation story starts from the software, and as we go further down, we were able to isolate and apply the same exact logic and bring out a hardware abstraction layer that I'll show you how that becomes important. So in the end, what you're left with on the hardware side is basically this, of course, the hardware data plane with all the sensors and the components that you get on the platform side, but of course, a bunch of components that you will, in all likeliness, either get from the ODM vendor or from the community like the ONL community, where you're able to extract things like the ASIC SDK as well as the platform module components that will integrate with higher layers of the stack. Therefore, when you consider not only the IOS-XR stack, but frankly, any vendor stack that you're dealing with, these are the essential layers that need to be delayered as you go further and further into a disaggregated space, whether this is software only or software and hardware disaggregation. And therefore, going back to the allegory I was speaking about earlier, much in the same way that Xuanzang introduced this spiritual renaissance in the context of Confucianism within China, I look at the stuff that's been happening within the OpenConfig community, or stuff that Facebook's doing with OpenR, or with all of the stuff that the OCP community has been doing with ONIE, with all of the white box hardware, et cetera, as sort of a similar, I would say, a spiritual renaissance in the context of vendor stacks. There is a huge influence from the community side, but also the way the markets for us as well as for our customers is shifting in the direction of disaggregating software as well as software and hardware combinations. I think it probably pays a lot of interest from our side to focus on solving this from a customer standpoint. There are service providers that are looking to disaggregate in the access space from our perspective, and we are looking to make sure that we provide the solutions that fit that space. I think one thing that I'll always reiterate in terms of how Cisco progresses with these architectures is that we, and frankly almost all vendors I believe, is that there is always a certain inflection point at which the vendors start investing more either on the disaggregation front or something that the community is interested in. And if you've noticed our absence for a few years, it's been primarily for this. We weighed against the customer ask, right? And therefore, when it becomes imperative for us to invest and work with the customers and with the community, we go ahead and make announcements, and that's what you saw in March this year. So as we progress further, let me give you a quick snapshot of what we have in progress consistently that we've been doing for the last year or so, as well as where we'll be progressing further in the next coming years. Right, so in order to understand the road to hardware-software disaggregation, let me bring back the entire conversation to the hardware-software disaggregation space. The software disaggregation is important, and I'll sort of talk about it even on the demo side. But when you come primarily to the hardware-software disaggregation, you are interested in how an integration actually takes place when you're bringing a software stack, which could be either vendor-driven or from a community standpoint or a custom stack that you might be running in your own network. And generically, I would classify the integration points into three types. There is the platform integration. And when I say platform integration, these are typical platform components related to the hardware, such as your sensors, fans, power modules, etc. And of course, you need modules, either kernel or user space, that you might integrate with in order to make this work. You also have the optics abstraction, and in my opinion, this is probably the space that requires the most effort, both from the vendor as well as the community side, to actually come to a consensus on how to solve the optics abstraction problem. We've been dealing with this problem from our side as well, and I think we're trying to work more with the community now to actually solve the optics abstraction piece. And the third one is the HAL piece, the hardware abstraction layer. If you remember the stack that I was showcasing, specifically how we did the hardware-software disaggregation, the HAL is the piece that we concentrated on primarily to solve a problem of disaggregating across multiple types of ASICs. And if you look at all of the work that goes into disaggregating and making sure a software stack works on a particular hardware, your focus really needs to be on the HAL layer, because most of the effort goes in integrating with a particular ASIC. Now, one of the benefits I think that we had in being able to do this fairly quickly from our perspective is that IOS-XR has been running on merchant silicon for a while, which means that we've already done a lot of investment in terms of integrating the XR stack with ASICs that the OCP community hardware also uses. Right? Specifically with ASICs from Broadcom, for example, where there has been a significant investment from our side early on, which ensures that if we have to pick out the HAL, we can take it from our existing stack and then focus primarily on the first two pieces that I've highlighted here, the optics abstraction and the platform abstraction. Therefore, when you start considering the decision stages that a customer and Cisco need to take when they're working together to actually disaggregate and make XR work on the platform of choice, I would classify the decision stages into four types. To start off, we have to consider how we select the hardware. I think this is a fairly obvious point, but this is critical in determining where we go with the next set of stages in terms of getting the right modules, making sure that we have the right support from the community, etc. And till now, we've seen this from a couple of standpoints. A lot of the network integrators and the customers that we work with primarily, of course, go with both port density in terms of what their network architecture intends to have, but also the ASIC and the platform capabilities that they will require from the perspective of the kind of traffic that they're dealing with, the number of prefixes that they want to program into the hardware, as well as whatever platform capabilities they need from the power perspective, the fans, etc. So typically, we've seen, at least till now, anything that tends to be OCP compliant, or at least in the new parlance, we call them OCP accepted and OCP inspired. So if we have platforms within the OCP ecosystem, we find it's easier for us, from the vendor standpoint, to get access to the modules that we require to actually integrate on the platform side. There is a huge focus on making sure, specifically in the Git repository that I'm indicating here, where you find modules for these particular platforms already published. As a result, when we choose a particular hardware, or I should rephrase, when a customer chooses a particular hardware and they come to us to help integrate, we primarily look there, right? And if we don't find something there, we do have to go to the ODM vendor and work with them, which certainly adds to our cycles. And that is why I would say that if something is OCP compliant from the customer perspective, it makes it easier for us to actually start the integration process fairly simply. And the second decision stage is, of course, integrating with the platform. Once you've selected the hardware and we make our way into the ONL Git repo, and we find the particular platform, the particular set of modules, primarily kernel modules at this point, which allow us to expose the functionalities of fans, sensors, optics, etc., from the platform to the higher layer stack, we're then able to extract that, compile it along with the IOS-XR stack, and make sure that the final image that you have contains all of the capabilities to expose these platform requirements to the higher layer stack through user space processes. And I think there are different ways in which you could do this. We've actually experimented with a couple of them. A lot of you would be, of course, would know what's being done on the ONLP side with respect to the ONL platform libraries. And yes, they help a lot, at least in terms of getting us going so that we know exactly what's supported by the hardware and how we expose that to user space. But what we are really looking for is for those capabilities to be at least exposed through the /sysfs paths. And those sysfs paths are something that we can read, push the data up to the software stack, in this case IOS-XR, and then make sure that we expose those functionalities through all of our show commands that you would typically have, as well as the YANG models that we expose. ONLP is specifically useful for us from the perspective of the write operations. With the read operations can be done from the sysfs paths in our case. You can use the ONLP, but we choose to go with the sysfs for our integrations. And the ONLP write operations, particularly in terms of managing fan speeds based on temperature information, etc., is something that we can leverage in tandem. We are potentially looking at moving away from ONLP from our perspective, and that is purely to simplify the number of components we have on the system. But in my opinion, both of these are important for any vendor to get going, at least on the integration front. And I've already mentioned the integration with the ASIC in itself. The ASIC SDK comes from the ASIC vendor. And we would have to deal with the ASIC vendor. You can take Broadcom, for an example, where either there is a prior understanding between the vendor, such as Cisco, and the ODM vendor, as well as probably an understanding between the network integrator, the customer that wants to deploy that hardware, and the ASIC vendor as well. And this particularly comes to light when you have to consider all the licensing concerns you might have with the particular ASIC vendor you're working with. I'm not going to touch upon those, but those are considerations that we have to take care of whenever we deal with any customer asking for a particular ASIC. So generically, the way we work with it is that we have licensing agreements with certain set of ASIC vendors. We're able to bring that to the table purely from a distribution standpoint. So if you're absolutely fine with us compiling the components into our stack and then providing an image to work with, then we can do that right away. It is possible to do a mix and match where you get the licensing and get your own set of modules, but it does require a validation cycle from our side to make sure that we have the right hooks to work with that integration. It is certainly possible to do something like an open API, like OpenNSL, for example, that Broadcom publishes. And it is entirely dependent on what our customers might ask us to do. At this standpoint, the integrations that we have in-house seem to be sufficient. If there are specific requirements to integrate with specific set of APIs, we can certainly start considering them in the near future. And last, of course, is creating an installer image. So once you have done all of the first 3 stages of selecting the hardware, doing the platform integration and the optics integration through the compilation process, and of course, determine everything you need to do from the ASIC integration, we move on to creating an installer image. ONIE is fairly acceptable for the current OCP ecosystem as the installation and bootloader paradigm. And so we can therefore use that as well as all of the documentation we have externally to create our own ONIE compatible image that we then publish and can be installed much like you would do any other image. All right, so a quick sort of pointer to what we are doing with the OCP community. At this point, we are fairly new to the process in terms of working with the community and also showcasing things that we have and can publish further. We are leveraging the components in the ONL Git repo. We are also currently using the sysfs paths to expose the read functionalities for our higher layer stacks to showcase the environment operations. We are also leveraging the ONLP write capabilities at this particular standpoint, but I don't know how long that might continue. But that is certainly one of the things that we are actively looking at. And of course, there's great documentation right now on the ONIE and the ONLP front, so that has helped us a lot in getting started from our perspective. And I think everyone has questions on what sort of hardware will you support. We came out with our initial offering and our blog indicating an integration with the 7816 Edgecore platform. This was the first platform that we worked with. It is an OCP accepted platform. I'm using the terminology I've been asked to. And the enabled platform, although it might not actually end up being a generally available platform, all of this is based on how we work with our customers. I can pretty much say that the 5916, which is also an Edgecore platform and an OCP accepted platform, should become available by the end of 2018. And the way we work with this, of course, is for you to ask questions on how can you start playing with iOS-XR on these platforms. We are in limited availability for this year, which implies that we are working with selected set of customers that have come to us and want to actually start deploying iOS-XR in their networks on OCP hardware. And for those, we do have limited availability, but that doesn't imply that you can't get access. Talk to your local Cisco systems engineer or account team to get in touch with us if you want it this year itself. If you're willing to wait at least till mid-2019, we are looking to become generally available on some of the hardware that I indicated earlier, as well as a couple more that might be in the offing. So in general, I would say that if you have any questions and you want to get in touch with us right away, head over to the email address I'm referring to here, and you can send us questions. Right? So this is just context of what's coming up. This is a quick look at what we have. And of course, for any questions, I'm going to be here right after the talk as well. Now, what I'd also want to quickly do, since we do have about a few minutes, is to show you hopefully a couple of demos, live demos, which showcase to you both XR running on an OCP hardware, or at least hardware that's been showcased at some of the OCP conferences earlier, and show you a couple of use cases. So one of them, the fairly obvious one, is that, so here I have, as you can see, and hopefully you can read it, here is a Delta platform. It's an Ajima box, a 9064, which was introduced and talked about by the Delta folks at, I believe, the 2017 conference. And they're currently actively working with the OCP community to become either OCP inspired or accepted accordingly. But this was also the first platform that brought about the Jericho capabilities within white box hardware, which is specifically interesting because we have those offerings on our side with respect to merchant silicon, but being on the white box side, this is a new offering that we'd like to integrate with. So let me start off and let this guy work its own magic in terms of installing the OS using ONIE, which showcases to you the fourth decision stage that I spoke about, being able to go into ONIE, download the ONIE compatible installer image, and then install IOS-XR on the system. Typical dialog that you're going to see as soon as you go into the ONIE stage. You can see the platform and the version. Excuse the naming of the image for now. It is fairly alpha image on this particular platform, but we'll have proper naming once this becomes generally available. So while this continues, what I can do is actually meddle around with an AS5916, which is actually the platform that should become available by the end of this year, which is using the Qumran ASIC from Broadcom. And as you can see, this is running a version 701, which is also most likely the versioning scheme that we will use when we make this available towards the end of this year. And this one is a 54-port platform with all of the 10 gig and 100 gig ports that you might need. Now, on this front, I also am connected to an NCS 5501, which is a Cisco version of the same exact platform, almost the same exact platform, a fewer number of ports, but the same ASIC, right? So I'm showing you back-to-back two platforms, one directly from Cisco with the complete integration, and the other one being an OCP hardware with XR running on top. And just to hammer in the point that I made earlier, that we invested both on the software disaggregation as well as the software hardware disaggregation, there is the slicing up of the network stack in terms of the APIs as well as the platform side. So when I, of course, do things like show environment power, I'm getting information from the modules that have been pushed into the kernel as we did compile the components that are provided into the ONL community by the 5916 platform. In addition to that, if you look at any of the other things like environment fan, the fan speeds are also coming from there. Bear in mind, the integration is still in process, so some of the fields will get populated. But we have seen, however, that some of the information is not available from the modules that are published currently. So we will be working with those ODM vendors to try and see that those fields can be provided. Like in this platform, we are certainly not getting the input voltage information for the power modules. Once that is done, you can also start looking at show inventory, typically to take a look at some of the pluggable optics module integration that is already working. So you can start working with the 10 gig and 100 gig optics, both Cisco as well as third-party supported optics that Cisco works with, and they will be supported as part of our integration cycle. And the last part of the demo, what I'll quickly do is go into running OpenR on both the platforms to show you the software disaggregation space, where I can basically have these two guys connected over a 10 gig port currently. It could be 100 gig port, doesn't really matter. OpenR will run inside a container in this case on the two platforms, send out its discovery processes, learn everything, act as an IGP, and then program the routes into XR. So, and I don't think I have it already running. Yep. So let me start it. Start it here as well. And once I've started these and they're running, what I should be able to do fairly quickly is show you a couple of the Breeze CLIs from OpenR. where, as you can see, we just established an adjacency between two OpenR instances running in the container on the XR box. And if everything went well, let me get out of the container. I should be able to do a show route in XR. And you see the application route, the A route. This route, as well as the routes in the IPv6 table, these A routes are being learned by OpenR distributing the prefixes on the system. So we're showing you a couple of disaggregation layers. One, we have a community stack, OpenR, integrating with a lower layer API on the XR stack, which we call the service layer API. And we're mixing and matching that combination of software by disaggregating IOS-XR itself running on white box hardware. So you've got OpenR running on XR on white box, right? And in exactly the same context, on the NCS 5501 running here, this is a Cisco platform, and we follow the same exact methodology, right? Yeah, this one's probably not even advertising. Oh yeah, I'm only advertising IPv6. And with this, what you can basically see is that the two platforms are running OpenR in exactly the same way. That's just our first step in making sure that we're able to work with the community both on the stacks that it produces as well as the hardware components that we have to work with in the current realm. And hopefully, yeah, this is almost done in terms of the booting process. And once that's done, you should be able to have things like the ZTP capabilities within XR that you can leverage as part of the software stack. So you can basically have the entire hardware provision by running ZTP scripts or your own ZTP config that you apply on top of the initial ONIE process that brings the image onto the system, right? So you basically have at least two stages of disaggregations that you can work with right away. And with that, I'd like to actually conclude since I only have 25 minutes. And if you have any more questions, I'll be around. So please feel free to come around. And in general, you have access to the couple of pointers that I've given. Send out an email to this if you have any questions. And of course, for the rest of the stuff, stay tuned. We'll be announcing more of it fairly soon. All right. Thank you.
So I think we could take maybe one or two questions,
Sure.
because I'm sure there's lots of interest here.
And so this aggregation of the software introduces a number of new APIs and layers where you can interface with your software, and also you introduce the hardware abstraction layers. Do you see the vendors converging on a common ground for these interfaces, and in particular for the hardware abstraction, what is your view on the stratum used there?
Okay, so at least on the API side, I know that there's a lot of convergence happening currently from the OpenConfig side. So even on the lower layer of the stack, I mentioned the service layer earlier, which is where we're integrating OpenR with, for example. There is significant investment on the OpenConfig gRiBi, which allows us to at least we can't say it's standardized, but at least it's going to be well adopted and hopefully consistent across a different set of vendors. On the higher layer manageability side, I think, again, the work that's been done both on the IETF front as well as the OpenConfig front will sort of bear fruit, and we expect at least the manageability layer to become consistent from that perspective for a large set of vendors. Now, this is entirely true whether you work with white box hardware or not, right? So these APIs will be consistent across all platforms. When you consider the hardware abstraction layers, I think that is a tough cookie because both vendors as well as the community is bringing out their own variants. There has been a lot of focus on using SI as one of the abstraction interfaces, but there is also a lot of customers that we deal with who have either created their own abstraction interface or they expect us to provide at least our variant of it. What we are doing in the short term is we're bringing out a model-driven API at the hardware abstraction layer from our side. The reason for that is that the southbound integration, which is integrating the ASIC SDK with our hardware abstraction layer, is where it takes the maximum amount of effort. The northbound side is where we need consensus, right? And therefore, while we will implement all of the things we need to support both white box and Cisco ASICs on the southbound side, on the northbound side, we'll provide a model-driven API. Currently, we introduced this in March, and we call it the open forwarding abstraction. The reason for this is that we want to be able to have an approach where if you want a SI interface on top of an ASIC that doesn't support it yet, we might be able to model it using our API. So you can still have a SI interface, but it'll be on top of our API, for example. It is also perfectly possible for us to instead integrate on top of SI using our XR stack. That requires investment, but which basically means that once you have the right resources from our side and from the customer side to work with, that is also a possibility. But considering the amount of time you might generally have to work with, we expect that if we model the interface that you need on the hardware abstraction side, it'll be far easier for us to take care of all the other abstraction integrations on our side. And therefore, our focus will be to try and mix and match, but try to at least meet the deployment timelines, right? At least what we've seen from our side is that customers tend to have different types of requests, but there is usually a compromise at the end based on how soon they want to deploy, right? So we work with them accordingly.
Okay. On. There we go. So in fairness to the rest of the speakers, I think what we better do is break here.
Okay.
You can stick around outside if people want to have conversations and ask more questions.
Okay.
Does that sound good?
That sounds
All
good.
right. Thank you.
All right. Thank you.